Okay, so I want to take a look here at another theorem. All right, this one, it appears pretty complex, but this one's actually much simpler to prove than Peirce's law. And if we take a look at what it says, it should actually appear pretty straightforward and obvious, and that should also give us an idea of what it is that we need to do in order to get this proof started. So this is a conditional, okay? And the consequent of the conditional is Q, and the antecedent is if P then Q, and if R then Q, and P or R. So that should seem like a pretty straightforward theorem. And again, the overall form of this thing that we're trying to prove, the main connective is a conditional. So this is a conditional. And so we should start the same way we would usually start trying to prove a conditional, which is to assume the antecedent of the conditional. So we need to bring all of this up here and start a new subderivation. So we're making this assumption for purposes of conditional introduction. And we're trying to show that Q is going to follow at the end of this subderivation. So what should we do here? Well, we have this long conjunction here. We should go ahead and take that conjunction apart. Remember, we should unpack the premises and take everything apart as far as we can and see what strategy suggests itself then. So let's first get the right-hand side of the conjunct. So we get P or R just by conjunction elimination on line 1. And now let's take this left conjunct, which is all of this. It's a conjunction itself. And we can go ahead and use conjunction elimination again to get these two conditionals on separate lines where we can use them. So we get that by two applications of conjunction elimination to line 3. All right, and now we have if P then Q and if R then Q, and we have P or R, so we should probably use disjunction elimination on this disjunction to show that we get Q in either the case of P or the case of R. So let's go ahead and start a subderivation with P first. We're going to do this for purposes of trying to do a disjunction elimination. Well, on the assumption of P, we get Q right away by conditional elimination, lines 4 and 6. And now we can go ahead and do the symmetrical subderivation with R. And this time Q follows from lines 5 and 8. Conditional elimination. And now we have on our line 10 Q from disjunction elimination. And again, we cite the line number of the original disjunction, 2, as well as the two subderivations, 6 through 7 and 8 through 9. So disjunction elimination. And now we're able to finish this off, line 11. Conditional introduction, lines 1 through 10. And that completes this proof. It was a lot simpler than it looked.